Hello, this is Dr. Cole Woolley, and this lesson is called Chiral GCMS. We are going to use Chiral GCMS now to add to the data that we already have from optical rotation and GCMS to once and for all determine the difference between Oman frankincense and Somalia frankincense. This all has to do with the word chiral or chirality. Now, the Chiral GCMS instrument is almost exactly the same as the GCMS instrument. How are they different? This Chiral GCMS has a chiral column. And with the chiral column, it will look at the molecules in the frankincense essential oil and separate the chirality of the molecules. So instead of there being one alpha pinene, we can separate it into two alpha pinene enantiomers. Here's what I'm talking about. Alpha pinene comes in actually two forms. They're two enantiomers. They're mirror images of each other. They share lots of the same properties, but in space, within the essential oil, they are two different. One's left-handed and the other one's right-handed. So as we're looking at this, the chiral column in the chiral GCMS will help separate them. This is an example of the saponine molecules, not one, but two saponine molecules or enantiomers. And they can be separated by chiral GCMS, as well as the two limonene molecules or enantiomers found in Somalia frankincense and Oman frankincense. Now remember, alpha pinene is found in the greatest abundance in both Oman frankincense and Somalia frankincense. And so alpha pinene will have the greatest impact on the difference between the two. We already saw that there is a difference between the optical rotation of Oman frankincense and Somalia frankincense. Oman frankincense had an optical rotation of plus 30 degrees, and the Somalia frankincense had an optical rotation of minus 13 degrees. There's definitely a difference, and chiral GCMS will detail this difference. Now let's look at the chiral GCMS of the monoterpene fraction of these essential oils. First of all, the Somalia frankincense. Notice that the minus alpha pinene is more abundant than the plus alpha pinene. In the Oman frankincense, the opposite is true. The plus alpha pinene is way more dominant than the minus alpha pinene. Let's look at this in closer detail. The Somalian frankincense, again, the minus alpha pinene is more abundant than the plus alpha pinene. Now this is a separation done because we have a chiral column in a chiral GCMS. Now if we look at the Oman frankincense, wow, the abundance of plus alpha pinene is so clear, and minus alpha pinene is so minuscule. Let's look at it in more detail. Again, the same separation. So the Somalia frankincense, if you combine both alpha pinenes together, represents 60% of the alpha pinenes, and the plus alpha pinene only 40%. So it's minus alpha pinene dominant. And then when you take the ratio of the plus versus the minus, you have something less than a value of 1, which is 0.07. That's really important. If you look at the Oman frankincense, well, we've got 95% of the plus alpha pinene and only 5% of the minus alpha pinene. So when the ratio is produced, the enantiomeric ratio of plus to minus, we get a value of 19. That's so significantly different. Now let's look at these chromatograms back and forth. Hey, see the difference? Well, this difference in alpha-pinene happens to be the major difference and the cause of the optical rotation difference. The optical rotation of Oman frankincense being plus 30 and the optical rotation of Somalian frankincense being minus 13 degrees. Well, these differences in optical rotation indicate that there's a difference in the chirality and the enantiomeric ratio of the two alpha-pinenes and the other molecules that are found in the essential oils. So once and for all, we use analytical tools like optical rotation, GCMS, and finally chiral GCMS to prove once and for all that there is a difference between the Oman frankincense in the north and the Somalia frankincense in the south. They are separated by the sea, and they've been this way for many, many years. And this has caused genetic drift. They are genetically different. This genetic difference causes the enzymes that produce left and right-hand alpha-pinene molecules and other molecules in the essential oil to be at various levels. And these levels of enzymes are related to the DNA drift. So this is all about how we used analytical instrumentation, optical rotation, GCMS, and chiral GCMS especially, to determine once and for all that Oman frankincense is distinctly different than Somalia frankincense. And it shows the power of analytical instrumentation to determine not only quality but differences between essential oils. I hope you enjoyed this.